How is it going today, pre-calculus type people? Hope you had an amazing day today. It's a beautiful day. We're going to be talking about help for the logarithmically challenged, just a cheesy title to go along with just a few more problems that you can do for logarithms. It's basically just going to be a few more situations. So to help you solve equations involving logarithms or exponentials, you're going to rewrite the equation with one term on each side, do an inverse function on both sides of the equation to undo the log, and then solve the resulting equation. So we've got a couple of things we're going to do here. And these are just a couple of different scenarios that you can do. I'm basically just throwing a bunch of different problems into the mix so that hopefully you can see a lot of different ways to solve these. Let me turn the brightness up just a hair. Number 1, it says log a of x equals 2 log a of 3 plus log a of 5. So fantastic. I can simplify log base a of x, this right-hand side. This is 3 squared and 5, so this is going to be log base a of 3 squared times 5, which is that going to be too bright? No, it's okay. Log base a of x, this is 9 times 5, which is 45. Log base a of 45. And then it says to use an inverse function. This is step 2. Use an inverse function on both sides. So the inverse of log of a, let me zoom in here, is the exponent. So using a base of a, I'm going to make both sides an exponent. Excuse me. And x is 45. So nothing new there. Just a couple of different scenarios for you. All right, number 2 says log, let's see if I can get this out of my way, sorry. Log 3 of x plus 2 plus log 3 of 9 equals 3. So I need to convert this as much as possible. Log base 3 of 9 is 2. That's 3 to what power gives you 9? So this is log base 3 of x plus 2 equals 3. So subtract your 2 over, you get log base 3 of x plus 2, excuse that, equals 1. And then 3 both sides. Use a base of 3 on both sides. X plus 2 is equal to 3 to the first power is 3. And subtract 2. So x is 1. No pluses and minuses there, so I can go back and check it again, and it turns out to work out pretty well in my favor. All right, next one here, there he is. Now on this one, because our bases are so whacked out, there's no way that I can make 0.3 and 1.7 into the same base, so I'm not even going to try. But what I'm going to do is I'm going to use the natural log on both sides, and I'm going to natural log here, and I'm going to natural log here. And what that lets me do, let me take that brightness down, it is a little bit bright. What I'm going to do is use the properties of logarithms. So this exponent can now be dropped down to the front. So it'll be 1 plus x, the natural log of 0.3 equals, this exponent drops down here, 2 minus x, natural log of 1.7. So again, make sure you keep those in parentheses, all right? We have a exponent with multiple terms, got to keep it in parentheses. So this is 1 times the natural log of x, or the natural log of 0.3, so this is the natural log of 0.3 plus x natural log 0.3, and then distribute this one here and here. And you get 2 natural log 1.7 minus x natural log 1.7. Alright, so I'm going to move my x term over here and move this natural log of 0.3 over here. So I'm going to end up with x natural log 0.3 plus x natural log 1.7 is equal to 2 natural log 1.7 minus natural log 0.3. All right. So again, I just shuffled my terms around, got my x's over to where they'll be positive, got everything else to the other side. Factor x out, you get x is, ooh, wow, excuse me, not equal to, x times, and this will be the natural log of 0.3 and the natural log of 1.7, right? Natural log, oops, of 0.3 plus natural log 1.7. You can probably see where I'm going to go with this. I'm going to simplify this other side. This will be 1.7 squared divided by 0.3. So the natural log of 1.7 squared over 0.3. And over here, I'm going to divide by, this is the natural log of 0.3 times 1.7. The natural log of, and this turns out to be 0.51. So I'm dividing by this part right here, so that all I'll end up with is x equals, divide by that over here, the natural log of 0.51. And it's just calculator work. You bust it out and you get negative 3.364. All right, so again, I natural log both sides, dropped the exponents, distributed the natural logs here, got all my x's to one side, pulled out the x, solved for x. All right. Number 4. Interesting question here, only because it has an absolute value sign on it. Apart from that, excuse me, it is trade relations. I mean, it's just trade relations. Where did that come from? No clue. It's par for the course. That's where I was going. Where did trade relations come from? Anyway, I've got a log, so let's go ahead and get rid of that. There's only one log, so I can go ahead and get rid of it. And I'll have the absolute value of x plus 4 is equal to 3 squared, which is 9. Now, when I get rid of the absolute value sign, what that's going to do is split it up to x plus 4 equals positive 9 and x plus 4 equals negative 9. That's how you split the absolute value. You say, well, this has to be positive or negative, so let's figure out what x is. Subtract 4 in both cases, you get x is equal to 5 here, and x is equal to negative 13 here. Two values. And then I go back and plug them in, because I have to check for extraneous. Remember, put in a 5, you get 5 plus 4 is 9. That's okay. Plug in a negative 13. Now, negative 13 plus 4 is negative 9, but can I have that? Is that okay? And the answer is yes, because of the absolute values. It makes everything okay, because it's all positive. So again, just a couple of examples, a couple good examples here. All right, number 5. E to the 2x minus 5 e to the x plus 4 equals 0. Okay, this one is going to be a little different. When you see e to the 2x written like this, this is basically saying that e to the 2x is the same thing as e to the x squared, right? Sorry. E to the 2x is basically the same thing as e to the x squared, because you would multiply these exponents and that'd give you e to the 2x. So let me rewrite this a different way, and I'm gonna show you a little trick that I like to use here. What if I called e to the x some other letter? Like, pick a letter. Why is it so hard to pick a letter? I can't use x. Let's call it z. That'll work. Let's call e to the x z. So this is basically z squared. So I'm going to skip some space and rewrite this. I've got z squared minus 5z plus 4 equals 0. And I'm calling e to the x z, right? E to the x equals z. So I'm just rewriting it here. Z's everywhere. Well, that's just a normal factoring question, because you have multiple powers of x, right? So you would factor it, and you would say z minus 4, z minus 1 equals 0. So z equals 4 and z equals 1, right? Well, we're going to do the same thing up here. Just instead of z, I have e to the x. So I can factor this, and it actually comes out to the same thing. Z being e to the x, you get e to the x minus 4, and e to the x minus 1. So if I was to multiply that back out and check my work, obviously, e to the x and e to the x is e to the 2x. Negative 1 e to the x, negative 4 e to the x is negative 5 e to the x. Negative 4, negative 1 is positive 4. Set them equal to 0, you get e to the x equals 4 and e to the x equals 1. Now this is where it gets a little bit different, because to get rid of e, I've got to natural log everything. So x is going to be the natural log of 4 and the natural log of 1. Which, by the way, and I'm going to skip down here for this one, so let me kind of separate this. The natural log of 4 is 1.386, and the natural log of 1 is 0. That's the point you're supposed to have memorized. The natural log of 1 is 0, so there's your answers. So either way you go, even if you came back down here and plugged in e to the x back into z, e to the x equals 4, e to the x equals 1, solve them. Natural log both sides. Okay? So just a few other examples, neat little stuff you can do here. Number 6, x squared e to the x minus 3 e to the x equals 0. I've got a subtraction symbol here. There's a couple of ways that you can go about doing this one. We've already talked about one of them where it's getting this guy to the other side. So I want to present a different one to you. Both of these have e to the x, so just take them out. And you have x squared minus 3 equals 0. Well, guess what? That's factored. That's completely factored now. So set your factors equal to 0. E to the x equals 0. X squared minus 3 equals 0. Natural log both sides. Here. Now, because of this, you cannot do the natural log of 0. X cannot equal the natural log of 0 because there is no natural log of 0. Remember, your natural log, let me show you this here real quick. The natural log of x does not touch the x-axis. I know it looks like it, but if you hit trace and 0, you're going to come up empty for y. Which is also why, back on here, if you hit the natural log of 0, comes up as an error. You can't take the natural log of 0. So this one is out of the range, so I don't care about this one. This guy, on the other hand, x squared equals positive 3, so x is going to be positive negative square root of 3. So we still have two answers. All right, y'all have a good one.